You guys are going to be able to see my screen. Yes, you can see it properly. So I can now see the chat as well. So don't stress if you guys send messages, I will see it. So what are we doing today? Remember, guys, we are carrying on with our revision of term 2 work. And so today what we're focusing on, if we look at my heading, we are revising our algebra. And so we start with example number 1. It's writing algebraic expressions. Now, we haven't really covered this directly in MathsLive, but because we know what expressions are and we know how expressions work, we should be able to take something like a story sum and we should be able to turn it into an expression. So if we look over here, and again, I put everybody's names in, so I don't know who's joined us today, but we have DeCarlo. If DeCarlo is with us, I didn't see. We have Mikuli, and we have Rory Sang. I don't think I saw any of those three with us today. But anyways, so it says DeCarlo has X sweets for lunch. I don't know why it says for lunch, just X sweets in general. You can't have sweets for lunch. And Mikuli has 3 less sweets than DeCarlo. Rory Sang has 3 times as many sweets as Mikuli. A is write an expression in terms of X. So in other words, whenever you see something that says in terms of X, we're just asking you to write the expression with X inside of it. Okay. So when we say in terms of X, it must include X in your answer. So write an expression including X for the number of sweets Nkuli and Rory Sang have. Do you guys have any idea how I would do that? Anybody? I see Uma is asking us why Google Meet today. We were just testing it out. We're testing it out because we're using Google Classroom. We just wanted to test out and see if what did I say? We wanted to see if our I'm blanking out so badly today. We wanted to see if the integration would be better between our Google Meet and Google Classroom than using Google Classroom and then Zoom. So Noctula, who is Tando, has said x plus 3 plus 3x minus 3. Okay, Tando, you're way ahead of everybody. First, tell me, what is the number of sweets Nkuli has? Write that as an expression for me. Just for the number of sweets Nkuli has. A 100%. Nkuli has x minus 3. Okay, so because Nkuli has 3 less sweets than DeCarlo, and DeCarlo has X sweets, we can say Nkuli has X minus 3 sweets. And then if I have to write an expression for Rory's son, what would that be? I see Itandila, you've also put the answer in the chat, so that was really good. Anybody want to tell me what would the expression be for the amount of sweets that Rory Sang has? Tando, you are correct. So Rory Sang has 3 times as many sweets as Nkuli. So in other words, I need to take Nkuli's expression and I need to multiply it by 3. But I can't just go x minus 3 times 3 because this is not, when we apply BODMAS, we're going to go 3 times 3 and x is not going to be multiplied by 3. So what we could do is we could go and we could put brackets around my x minus 3, which is fine. But the easier way to do this is just to say 3x minus 3. because we're still multiplying x minus 3 by 3. So immediately, it's not just x times 3, it is x minus 3 times 3. Why? Because Rory-san doesn't have 3 times as many sweets as the Carlo. The Carlo has x sweets. So if Rory-san had 3 times as many sweets as the Carlo, then we would say 3 times x. Rory-san has 3 times as many sweets here as Nkuli. And so because Nkuli has x minus 3 sweets, we have to multiply x minus 3 by 3. And that's how we get this expression over here. So now that we have that, what I want you guys to do is I want you to try out the reactions button. And I want you to send through a thumbs up. There we go. Kamo has sent through a lot. Itandile, Kaylee, lots of thumbs ups. Okay, so that's cool. So I think with this reactions button over here, I'm not really going to see anybody who is sending a thumbs down. So with a thumbs down, send a no. Just say no in the chat. Say no for me, please, if you are not with me. Or ask your question. Ask your question. Okay, Uma, I see all your thumbs ups. Thank you. Liako is happy, celebrating. Okay, I'm not seeing any questions on this so far, so I am going to move on. Now, Uma, reactions are nice and cool and everything, but it will get a little bit distracting for everybody if we continue to spam. So let's not spam, guys. Let's just, send through 1 or 2 when it's asked for. Beyond that, let's not spam reactions. Moving on, it then says the Carlo has 15 sweets. Okay, how many sweets do Nkuli and Rory-san each have? Would you guys be able to tell me that? Anybody? Anybody want to tell me how I would do it? Bree, you are 100% correct. We substitute. We knew that the Carlo had X sweets. Now what they've done is they've basically told us that X is 15. So if the Carlo has 15 sweets and Kuli has 3 less sweets, well then we can substitute X for 15. 15 minus 3 is going to be 12 sweets for Kuli. And what about Rory-san? Okay. Somebody want to help me with that? Imithle has told us Rory-san has 36. Well, let's check Imithe's answer. So we substitute 15 for x minus 3. That's going to give us 3 multiplied by 12. And then we have 36. So Kaylee, 100% correct. And you see how I have then done my working out for that expression you've given me in the chat. And you'll get your answer as 36 sweets. Okay. Moving on. It says if all together. So now ignore that the Carlo has 15 sweets. There's a new scenario now. If altogether they have 113 sweets, how many sweets does each person have? Is that a raised hand that I heard? Yes, Itandile.
So, good afternoon, ma'am. Ma'am,
Afternoon.
we're gonna have to from the 13, ma'am. I was planning to divide.
Mm-hmm.
Or, ma'am, can I change it into a ratio?
How would you do your ratio?
I would say 13
Mm-hmm.
to 12 to 35.
Where are you getting the 13 and the 12 and the 35 from?
Oh, I was gonna say, ma'am, I was gonna say 113
Mm-hmm.
to 12 from Goody Seats to 36
Mm-hmm.
from Murray Songs, and then
Okay, so look at this, Itandile. Ignore B. Ignore my
Yes,
answer that I got from here and from this.
yes,
Because
ma'am.
this was just an if scenario. It said if Decalo had 15 sweets. This
Yes,
is
ma'am.
how many sweets Nkuli would have, and this is how many sweets Rory Sang would have. Now it's a new scenario. It says if all together they have 113 sweets. So when you add up the Carlo sweets plus Nkuli sweets plus Rory Sang sweets, you get 113. How would
Yes, ma'am.
you use that information to be able to calculate how many sweets each person has? So let me give you a hint over here. Can I create an expression for the total sweets between the three friends?
Yes, ma'am.
What would that expression be?
Can't we say x
Mm-hmm.
uh plus minus divided plus 113?
No. So remember, 113 is how many sweets they have all together.
Yes, ma'am.
Okay. And so what I want to do is I basically want to say, well, my total sweets is gonna be equal to the Carlos sweets plus Nkuli
Equally
sweets
sweets.
plus Rory Sangs.
Songs.
Right. Now, Itandile, without giving me actual like numbers from previous questions, can you tell me how many sweets does the Carlo have?
It has x, ma'am.
X sweets. Okay. And how many sweets does Nkuli have?
She has -3 from the Carlos sweets.
She has -3 of the Carlo sweets, which means she has X -3
-3.
sweets.
Yes, ma'am.
Right? So what I'm gonna do here is I'm plussing and think of it as substitution. My expression on the top here tells me to plus, and then I have to plus Nkuli sweets. And
Yes,
Nkuli sweets is X -3.
yes,
You
ma'am.
with me?
Yes, ma'am.
And then what is the expression that we figured out for Rory Sang sweets?
3 bracketed x -3.
So I'm gonna add Rory Sang sweets. Uh-oh, that's supposed to happen. You with me there?
Yes, ma'am.
Okay. Now that we have this, let's simplify our expression. Let's remove brackets, add like terms, all of that fun stuff. So how would I do that?
I would say x
Mm-hmm.
um x plus.
So Itandile, let me ask you a question super quickly.
Yes, ma'am.
What do I have to do with the sign outside my brackets?
You keep it as it is.
No, not quite. So remember, when we want to remove our brackets, we
We
take the
distribute.
sign and we distribute it in. Yes, you are correct. So tell me now, if I'm removing my brackets, a positive times a positive x gives me what?
A negative x.
Positive times a positive.
Oh, it gives you a positive, ma'am.
It gives you a positive. Just a little reminder, when we have the same signs, my answer is positive. So negative and negative is also going to give me a positive. It's only when our signs are different that we get a negative answer. Okay, so right now it's going to give me a positive x over there. And then tell me a positive times the -3 will give me what?
It will give you a -3.
A -3. So can you see we've gotten rid of that first set of brackets?
Yes, ma'am.
Now, how do I get rid of my next set of brackets?
Ma'am, here we distribute 3. So it's
Not
going to be
just 3. Remember, we're distributing
positive,
positive
positive
3.
3. So,
Yes.
ma'am, positive 3 times uh positive x, which is positive 3x.
Okay, sorry, I'm just so you said pos. Oh, hold on. That I need that equals to. So you said positive 3x. I heard that, and then
Positive 3 times negative 3 is negative 0. It's 0, ma'am.
so remember we're multiplying.
Oh, it's going to be negative 9.
Negative 9. Now, what's our next step here, Ethan?
Ma'am, our like terms.
What are like terms here?
Our like terms is x,
Mm-hmm.
x plus x,
Mm-hmm.
and that's it. Oh, and negative 3 and
Mm-hmm.
negative 9.
Okay, and you're missing one.
Then positive 3x is alone. Oh,
No.
it goes.
So remember, this is a good point for us to recap this. Remember, when we are dealing with like terms, I don't know why that pen is so thin, but let's go with it. When we are dealing with like terms, we are looking only for same variable and for the same for the same exponent. Okay? And so, very, very important, it does not need the same coefficient. Okay? So here you thought that because it was 3x, that's spelled wrong. Efficient. Yes, I have an extra F there. Efficient. So essentially, you thought that because it was 3x and it didn't have the same coefficient, you thought it wasn't a like term. Am I right?
Yes, ma'am.
Right. But remember now that when we are dealing with these like terms, very, very important, it only has to have the same variable and the same exponent. It does not need to have the same coefficient. And that is why x and 3x are like terms. With me?
Yes, ma'am.
That's why negative 3 and negative 9 are like terms, because they have the same variable, which is no variable, and the same exponent, which is the exponent of 1. Okay, so now that we've highlighted our like terms, can we add them up? Tell me what you get.
Ma'am, I get 6x.
How did you get 6x? Let me know.
Oh no, ma'am, I got 5x because the coefficient of of x is 1, invisible
Mm-hmm.
1, plus the 3, which is 5x,
Mm-hmm.
because we can only take one variable.
Mm-hmm.
And then we say negative 3 minus 9, which
Mm-hmm.
is 12. Negative
Mm,
12.
yes. Okay. Can I simplify this more, Itandile?
No, ma'am,
Why not?
because there are no like terms.
Like terms. 100%. So this is now my new expression for the total sweets that they all have together. Now what I'm telling you is that all together they have 113 sweets. Do you think you know what you're going to do here?
Yes, ma'am.
What do you think?
Ma'am, since our total is 113,
Mm-hmm.
our y is going to be 113, and
Mm-hmm.
we are going to for our negative 12, we're going to cross it through our bracket, and it's going to be positive 12. So it's going to be 113 plus 12,
Oh, yes, you're right. Sorry, my bad. Mm-hmm.
which after we say that it's going to be 125 equals to 5x. We're going to
Mm-hmm.
divide both sides divided by 5, and then for 5x we're going to cross out 5, and we for 125 divided by 5, ma'am. We are going to have 25.
25. Okay, happy with that, Itandile?
Yes, ma'am.
So, what I want you guys to do, Itandile, stay with me because we're not done with the question just yet. But I want to
Yes,
see
ma'am.
some thumbs ups in either the chat or the reactions. You guys can decide to let me know that you're with me here. So we have Tando with us. Liaho has a question. So Itandile, you can just mute yourself. I'll call you back when I have another question for you. Liaho, yes.
Oh, ma'am, can I please go to the bathroom quickly, ma'am?
Oh, Liaho, don't be silly. Of course you can.
Okay, ma'am, thank you.
Pleasure. That was funny. Hey, Liaho's taking a bathroom break. Itandile, you can come back now.
Yes, ma'am.
You can then tell me now. Did we answer the question as yet?
Ma'am, I don't think we're done
You
at
don't
some
think we're
point.
done? What do we still have to do?
I'm not actually sure, ma'am.
So we know now that the color will have 25 sweets because he has X sweets. Do I know how many sweets Nkuli is gonna have and how many sweets Rorisang is gonna have?
No, ma'am.
No. So let's do that quickly. So how many sweets will Nkuli have? Well, now we
Ma'am,
know. Mhm.
ma'am, didn't they say 20? She has 3 less than
Yeah,
the color, which is gonna be 22, 23?
22. Remember 25 minus 3, we're gonna get 22.
Yes, ma'am.
Mm-hmm. And then for
And
Rorisang,
it said we have 3 times.
mm-hmm.
So we're gonna have to say, is it 22 times 3 or 22 plus 3?
So it's gonna be times 3. So it's because it's times, that means multiplication. So he has 3 times as many sweets as Nkuli has. So we're going to multiply Nkuli's sweets by 3. And what do we get there?
66.
66. Okay. So that is that. I just wanna see where Kamo went wrong. Kamo, so I think you said 3 times 25. 3 times 25, yes. So remember, Rory-san has 3 less than Mikuli, not 3 less than Decalo. Decalo has 25 sweets. So we can't say 3 times 25. We have to say 3 times 22 because Rory-san has 3 times the amount that Mikuli has. Okay, great. You see your mistake. We have Rupi saying my name. So I'm assuming it's either Decalo, Mikuli, or Rory-san. You can let me know. So that's that. So Itandila, you happy now that we have answered our question? We've told them how many sweets each person has.
Yes, ma'am.
Okay, thank you for answering that very long one with me. Moving on. I want some more thumbs ups, please, to let me know that you guys are all happy and all understand. Hey, I see Kaylee, Kamo, Imise, I saw Itandile. Yeah, oh, great. Yes, Rorisang, I know you will not be able to change your name, unfortunately, with Google Meet when you join. It's just the Google profile that you join with that's the name that's gonna show. But now that you've told me Rorisang, I will remember that Rupi equals Rorisang. Cool. So that's that on that. Moving on. Sorry, you may or may not have seen the prayer break. Moving on. Oh, no, before we move on, what I want you guys to remember now, we have sort of done revision on what like terms are. We've done revision of how to add and subtract like terms. So we haven't really touched really on our exponent rules as yet, but I'm hoping that you guys are all up to date and up to speed with that. Yeah, and so we've sort of now seen how to take a word problem, turn it into a expression when needed, and at the last bit, we turned our expression into an equation to solve for x. So that was that. It's a little bit of sorry, let me get my words correct. It's a little bit of critical thinking that we all need to apply. But yeah, I see that nobody really was like confused in the chat. You guys were putting in the correct answer, so that's cool. Yes, 100%. Everybody needs to memorize exponent rules. It's not something that will just pop up. They give it to you in a test. You have to memorize it. That's the only way you will know. So cool. That's cool. Now moving on to example 2, or rather revision block 2. Consider the following expression, very complicated looking expression, and I want you guys to tell me how many terms are in this expression. Uma, we're going to go into a brain break like Liafo said in 10 minutes. I saw a hand raised. Yes, Rory-san.
I think 4.
4. Okay, tell me which 4 do you think?
Where is it? Oh yeah. 2x plus 10 is 1. Y plus 2 is the R2, and then 1 plus y plus 3 over 3 is 3, and then plus 1.
Okay, so your answer is right, but not when you told me which ones you divided into terms, it's not 100% correct. And let me tell you why. Rory-san, can you tell me what are terms?
Terms.
Mm-hmm.
Yeah, I don't know.
How did you know that there were 4 terms here? How did you know? What made you say, okay, this is a term, this is a term, and this is a term?
By seeing the expressions like plus, minus, those kind of things.
Okay, so terms are separated by plus signs or minus signs. So Rory-san, why did you say y plus 2 was one term when there's a plus over here? You were
Ma'am?
right. You just put it out there. You told me that y plus 2
Oh,
was one term. Why? That's correct. But why is it one term when there's a plus in the middle there?
ma'am, I think it's because of the brackets.
100%. When we're trying to identify terms, we ignore signs that are inside brackets because I always try to think of it as like a rope or like somebody holding something together, right? It would have been
Yes,
two
ma'am.
terms, but because there's that bracket, the brackets are sort of grouping everything together. Now, Rory-san, let me show you where you are wrong. So let's erase this a little bit. So you are correct. Here's a plus over here. So that has separated this term, and there's a plus over here. So we have
Yes,
separation.
ma'am.
But Rory-san, can you see there's also a plus here?
Yes, ma'am.
So actually 2x is a term by itself. And then 10 times y plus 2 is also a term by itself. Because can you see between 10 and my brackets, is there a plus or minus separating those two?
Ma'am?
I'm saying between 10 and my brackets. So in other words, here's 10. Let me get out a pen. Here's 10 and here's my brackets. Do you see a plus or minus in between those two separating them?
No, ma'am.
No. So can you see why they are actually one term and why 2x is a term on its own?
Yes, ma'am.
100%. And we have Uma in the chat who has also corrected us. So that's great. So thank you, Rory-san. You were right, but not 100% correct. But I'm glad that you figured out how to separate your terms. That was super well done. Thank you for answering.
Thank you.
So we have 4 terms over here. Our next question is, what is the coefficient of x? Itandile, you're saying no. Hold on. Okay, I did see a lot of you guys were saying 4, so that was good. Itandile, I'm not quite sure what you were saying no for. Um, as for the coefficient of x, it's 100% 2. Can somebody tell me what the coefficient of y is? Well, I suppose there would be 2, but specifically this y over here that I've just circled. What's the coefficient of y? It's not 1. Uma is close. It's not 3 over 3. Remember, if I separate this out, it's y over 3. I know the coefficient looks like it's supposed to be 1, but actually, if I remove this y, it's actually 1 over 3. So keep in mind, guys, whenever we have a variable inside a fraction and they ask you for the coefficient, you're going to take the coefficient in front of the variable and the denominator. So can you guys please put some reactions in the chat or using the actual reactions button to let me know that you understand why my coefficient of y in that case was 1 over 3. Okay, lots of thumbs ups that I'm seeing. I saw a thinky face. Who was thinking? Who was unsure? Anybody? Okay, Ethan, what's bothering you? Okay, Itandile Oimise, please ask a question and I will be happy to explain where the confusion is. Rory-san, I'm just muting you super quickly. Oh, sorry, there you go. The y over 3 coefficient. Okay, so Itandile, all I'm saying to you is, if we have a variable that's inside a fraction, so it's y plus 3 over 3. So immediately I know when I'm looking at the coefficient of y, this plus 3 is not relevant to me. So what's left here is y over 3. If I was just doing it normally, I'd say, okay, the coefficient is 1. But when we have a fraction that has a variable, when I'm looking for my coefficient, I have to include the denominator as well. And let me tell you why. Remember, my coefficient is basically what's being multiplied to my variable. If I multiply 1 times y, am I going to get y over 3? No, I'm not. Because remember, this y plus 3 over 3 can be broken up into y over 3 plus 3 over 3. So if I take 1 times y, I'm not going to get y over 3. But if I take 1 over 3 and I multiply it by y, well, then I will get y over 3. So when you have a variable in a fraction, what you want to do is, the first thing you want to do is separate the fraction, if you can, if you are able to, which we could here, separate that fraction until we have the variable as a numerator on its own. And then what we're going to do is we take the number in front of our variable and the denominator. And that is how I got 1 over 3 as my coefficient. So Itandile, I hope that made sense. If not, and immediately, if you're still super confused, we can talk more about it. Okay? Itandile understands, that's cool. Immediately, if you're still confused, Feel free to stay after the lesson and let me know what you thought. And then we have the next question. What is our constant term? What's the constant? Can you guys tell me? Oh no, did I just open Teams? Yep. Constant is +1, 100%. So some more revision. Remember, what is a constant? The constant is no variable. It's a term. Should I say? It's a term that has no variables. It does not change. And in our case, that would be the term that is +1. And then it says if x is equals to 1, y is equals to 3, determine the value of the expression without a calculator. So I'm going to just put that down. You can see sort of what our brain break is. And like I said, it's a tiny one because I knew this lesson was going to be long. So moving on, what we're going to do here now is substitution. And you guys should be very familiar with substitution. So we're going to say 2x plus 10y plus 2 plus y plus 3 over 3 plus 1. So they have now told me that x is equals to 1. So wherever I see x, I'm going to put in 1. I'm going to substitute 1. And wherever I see y, I'm going to substitute in 3. And so let's do this. We're going to say 2, and instead of x, I'm going to write 1 plus 10, and instead of y now, I'm going to write 3 plus 2 plus, and instead of y, I'm going back over here to 3 plus 3 over 3 plus 1. Can somebody give me the answer to this question? Kaylee, I see you've put in the exact thing that you were supposed to have, which is great. Is it the exact thing? Plus 3, plus 3. Yes, over 3. Yes, good. So if we simplify the brackets over here, this is going to be 10 times 5 plus 3 is going to give me 6 over 3 plus 1. Simplify it a little bit more. 2 plus 50. 10 times 5 is 50 plus. Somebody tell me what is 6 divided by 3? Thank you, Tando. 2 plus 1. And now we can add up 50, 54, 55. 100%. So thank you guys. I see all your answers in the chat. Super, super well done. You guys clearly did not need my help with that one. Okay, so that is that. Moving into our brain break, like I said, a tiny one. Also, I didn't expect us to be using meat. So I don't know if this is gonna fit. No, it's not. So you guys, I don't know if you guys can actually let me know in the chat. Can you zoom in? Can you zoom in on my screen? Meat fishes, yes. Somebody said the eggs. Lillian, Lillian, do you have a different name or is Lillian your name? How do I do this? The eggs. Where's the eggs? Yes. So we have the eggs. Shady. Okay. Thank you, Shady. 5 minutes. Also, we started at 17 past. So 20 past. We will thingy will be. Sorry, I'm blanking again. 20 past. We will. No, okay. 21 past. We'll stop looking for differences and see what the differences were. Uma, I'm really sorry if you don't like the brain breaks, but you don't have to participate if you don't want to. Okay, we have hands up. Ethan Delay, yes. Do you have something?
Ma'am, if you can see the difference, like the what do you call this? The spice something 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 on the corner on the right.
Corner
The
on the
difference
right.
is
Oh, this thingy, my Bobby.
yes, ma'am, and this side it's faced down.
100%. Thank you, Itandile. Is that all that you have?
No, ma'am.
Okay, Itandile, I'm gonna let you do one difference. If the rest of the people who have their hands raised hasn't found the one you found, then we'll get
Yes,
back to
ma'am.
you.
Yes, ma'am.
Okay, who else is raising their hand? Let me ask. Okay, Liahu, you are next in the queue.
Ma'am, this is actually not for the brain break, ma'am, but
Mhm.
ma'am, you made a serious mistake, ma'am.
What
Instead
did
of
I
saying
do?
brain break, you said rain break.
Oh, I see. I
Yes,
see.
ma'am.
Sorry, I think actually, there you go, Liahu.
Yeah, yes, ma'am. Now it's fine.
Yeah, thanks, Liahu, for that one.
You're welcome, ma'am.
Um, okay, we have Imise next. Imise, do you see a difference?
Hi, ma'am.
Hi.
Ma'am, one of the differences I saw is the the
Mm-hmm.
the wait. I just want to quickly look for
Did
it.
you lose it?
I think I lost it now.
I'm just highlighting the differences that we have in the chat so far. Kaylee said dried lemon. Oh, Kaylee, sorry, I saw that you have your hand up. I hope I didn't steal your thunder.
Oh
A
wait,
shaker
I
of
think I
salt.
lost it now, ma'am.
That's okay. You take your time. I'm gonna take the rest of the hands though. Thank you, Emilia. Kaylee, yes, Kaylee. Did I get the one that you wanted to show me? The dried lemon.
Yeah, but ma'am, I found another one.
Which was your other one?
The glass.
Which
It's
glass?
like the glass of like juice or something. It's
Oh, I
tilted to the
see.
side.
Okay, yes, the position of this lemon, 100%. Thank you, Kaylee.
Yes, ma'am.
Okay, then we have Rory Sang. Yes, Rory Sang.
Ma'am, behind the glass, there is like, I think like those white chocolate or something. There's only
These
4
things.
on the left side, and then there's 5 on, yeah, that one.
Thank you, Rory Sang. And then I saw Refillware had their hand up, but they seem to be disappeared. Itandile, yes, do you have another one?
Yes, ma'am. The cup on the other side has a handle. The other side doesn't.
100%. Thank you, Itandile. Another one?
No, ma'am. That's it for me.
Thank you, Liapo. Yes, do you have one for us?
Ma'am, I'm doing the next one.
There's no, this is it, Liapo. This is our brain break.
This is, ma'am,
Ma'am,
this
can
is
you
it.
please?
Okay, ma'am.
Ma'am, the
I ma'am,
name
then
at
I
the
don't know, ma'am.
bottom.
No, the name at the bottom doesn't count. You guys are going to be very mad at the other ones. What I remember is if you look at the strawberry, there's a green thingy on this one and there isn't on the other one.
Okay.
The other one is there's a seed here and there isn't on the other one. How many do we have now? 1, 2, 3, 4, 5, 6, 7, 8. Yo, what was the other ones? And what phone do I have? I'm sorry. I'm sorry. Wait, I'm seeing Lillian. Lillian is in our chat. Who? Someone told me who was Lillian. Lillian, I forgot what.
Shady.
Thank you. Thank you, Shady. Okay, let's have a look at what the other ones were because this one was difficult before we move on. There. Okay, so we got the strawberry, we got the seed, we got the lemon, we got the handle, we got the lemony thing here. Oh, this one you guys would have never gotten. There's like a chip on the wood on the side that there isn't on the side. If you can see that. Crazy. It took me so long to do this. Then there was also something wrong here. We got the egg, we got that, and we missed this little leafy thing. Which, to be honest, I still don't see the leafy thing. Truly, I I still don't see what's the issue here. I don't know. But that
Oh,
was,
ma'am, I do.
what
The
is
other
it?
one's tilted at a different angle. The other one's tilted at a different
Oh,
angle. So,
that was so dumb, man. But anyways, yes, that was our brain break. Oh, I should erase all of my circles here, probably. Okay. How do I do this? Do. Done. That is that for our brain break. Sorry if you guys were like, ma'am, this is not a brain break. Anyways, moving on. We have simplifying our algebraic expressions, which is what we came here for. So, Inifle, I'm gonna mute you super quickly. Oh no, I can't. Oh no, I can. Okay, you muted yourself. Cool. Um. Okay, so anybody wanna help me answer? Question mark.
Oh, ma'am, I wanted to ask, ma'am. I just wanted to
Mhm.
ask, ma'am. Did you customize the brain break for us? That picture, did you customize it?
No, I didn't. I got it off
Oh,
the
okay, ma'am.
internet.
Oh, okay, ma'am.
Yeah, I'm not that smart, yeah.
Okay, ma'am.
Okay, Itanila, your hand is still up. Are you answering, or was that just from the brain break? We have Rupi, who, if my brain is correct, is Rory Sang.
shady, ma'am.
No, Shady was Lillian.
Oh, okay. Forgot. Okay.
Rory Sang, you with me?
Yes, ma'am.
There we go. I was correct. You're helping me.
Yes, ma'am.
Okay, cool. Let's go. What's first?
Ma'am, if I'm not wrong, I think I'm gonna divide 3 with 6.
You are wrong. Let me tell you why.
You.
Remember our rules to simplify. We have to identify our terms, simplify each term by itself, and then number 3, we can add or subtract like terms. Do you remember these 3 rules, Rory-san?
Yes, ma'am.
Cool. Tell me now, how many terms are in this expression?
2.
Why 2? Where, or rather, where 2?
Mm,
Are you saying this is
yeah.
one and this is another one?
Yes, ma'am.
That would be incorrect because remember, terms are separated by plus or minuses. There are not, there is not one plus or minus in this entire expression. So this entire expression is one term. So now that we have that out of the way, Rory-san, the first thing we have to do is, as part of our sub rules, if we have a fraction, we have to simplify the numerator and then simplify our denominator and then simplify the whole fraction. Okay?
Yes,
Okay.
ma'am.
So now we're simplifying our numerator. We have 3a all squared. How do I get rid of that exponent over there? Because remember, we're using BidMath. So my brackets, yeah, I'm dealing with brackets and exponents. So how do I get rid of this exponent of 2 outside? What would my answer be?
9.
Do you see 9a
Yes.
squared? How did I get that? I squared 3 and I squared a. And 3 squared gave us 9 and a squared gave us a squared. You with me on that?
Yes, ma'am.
Cool. Then we have multiplication, and let's get rid of our other bracket and exponents. What is 2a cubed going to give us?
6a to the power 2. 3 to the power 3.
What? There you go, to the power 3. And remember, 2 cubed is 2 times 2 times 2. What's 2 times 2 times 2, Rory-san?
6.
Mm-mm.
8, 8, 8, 8, 8,
8.
8.
There you go. Okay. Now we have this. Let's go and let's simplify our numerator a little, our denominator a little bit more. Well, there's nothing really for me to simplify in my denominator because there's no exponents outside my brackets. So Rory-san, I'm just going to get rid of my brackets. Do you see that?
Yes, ma'am.
Okay. Now in our next step, let's multiply across. So let's multiply 9a squared times 8a cubed. What rule can I apply here, Rory-san? Do you know?
Like terms.
So remember, like terms is we only use like term rules when we have addition or subtraction. When we have multiplication or division, what do we use?
Can you please repeat?
Okay, so when we have addition or subtraction, that's when we use our like term rules. When we have multiplication or division, which rules do we use?
Which rules? I might
I've
guess,
written it
ma'am.
up
I
here.
think exponent.
Exponent rules. Now, Rory-san, when I have exponents or rather powers that are being multiplied and they have the same base that's being multiplied, what can I do? What's the rule there? Do you know?
Ma'am, I'm a plus my exponents together.
You are 100% going to plus the exponents together. So let's use SNV. Okay. The first thing I want to do is deal with my signs. It's a positive times a positive, which is going to give me what, Rory-san?
Ma'am?
A positive times a positive gives me what?
A positive.
A positive. Thank you, Shady. And then let's multiply our numbers. Okay, so here it was a positive times a positive. My numbers is 9 times 8. Rory-san, do you know what is 9 times 8?
72.
Oh, good job. So that is going to give me 72. And then my variables is a squared multiplied by a cubed. So if I apply my exponent rule there, what will my answer be?
A to the power 5.
A to the power of 5. And do the same thing for me now at the bottom. Let's apply SNV to 6a to the power of 4 multiplied by 12a. My signs are going to be positive times a positive, which gives me what, Rorisa?
A positive.
A positive, 100%. And then it's, what are my numbers that I'm multiplying here at the bottom, Rorisa?
6 times 12.
100%, 6 times 12. And what's the answer?
Oh, you want the answer?
No, you're right. The numbers are 6 and 12. What is 6 times 12?
Oh,
What's the answer to that?
72.
100%. 72. And then we have a to the power of 4 times a. If I apply exponent rules there, what do I get?
A to the power of 5.
A to the power of 5. And now if I simplify this all together, what will my answer be? 72a to the power of 5 divided by 72a to the power of 5.
1.
1.
1a to the power of 1.
So it's not going to be a to the power of 1. It would have been a to the power of 0. Okay? And remember, a to the power of 0 is just 1, which means 1 times 1 would have just been 1. Happy, Rory-san?
Yes, ma'am.
There you go.